All right, welcome. And I want you to forget everything you think you know about math class. Seriously, today we're not doing math, we're becoming code breakers. We are going to crack the code of algebra, and I'll show you how this secret language doesn't just solve equations, it powers pretty much everything around us.
So, is algebra really a secret language? Oh, you bet it is. Think about it. It's this whole system of symbols and rules that lets you decipher really complex puzzles and unlock some powerful ideas. It's a language that we humans invented to describe patterns and solve problems that, honestly, simple numbers just can't handle. And today, you're getting the key.
Okay, so every secret language needs its symbols, right? Well, in algebra, our main symbols are called variables. A variable, usually a letter like X or Y, is just a placeholder for a number we don't know yet. It's the mystery in the message. It's the blank space that we're here to solve.
Ready for your first lesson in code breaking? We're going to start with the absolute basic moves. If you can master these, you'll have the fundamental skills to crack any simple algebraic message that comes your way.
Every good code breaker needs a key. And for our first mission, this is it. A stands for the number 8, X is 4, and Y is 5. Pretty simple, right? So let's put it to use.
All right, here we go. Our first coded message. 5x plus 2y. Now, it might look a little cryptic, but remember, we have the key. Our mission is to translate this string of symbols into one single understandable number.
So how do we decode this thing? It's actually really straightforward. First, we just swap in the values. The x becomes a 4, and the y becomes a 5. Next, we do the multiplication. So 5 times 4 is 20, and 2 times 5 is 10. The last step? Just some simple addition.
And bam! 30. Message decoded. You've just solved your very first algebraic expression. You know that feeling of clarity, when the confusing letters suddenly become a clear number? That's what this is all about. You've just turned a code into an answer.
Okay, you did great. Let's level up. Because real codes, they have layers of complexity. In algebra, one of those layers is something called powers, or you might know them as exponents.
So here's our next challenge. Check this out. 2x squared. See that little 2 floating up there? That's the power. It's a new instruction in our code. We still know that x is 4, so what do you think the first move is?
Now, this is absolutely crucial. With powers, the order you do things in is everything. It's like the grammar of our language. If you get it wrong, the whole message gets scrambled. You have to handle the power first. So 4 squared is 16. Then, and only then, do we do the multiplication by 2.
And there you have it. Our final decoded message is 32. See how that works? By adding just one new rule, handle the powers first, we can easily solve a much more complex code. Your skills are already getting sharper.
All right, now we're getting to one of the most powerful and honestly one of the coolest parts of this language, the rules of grouping. Get ready to see how a single tiny symbol can completely change the meaning of a message.
Okay, for this next part, we've got a brand new code key. We're working with a fresh set of values, and the one to remember for this next puzzle is that x is now equal to 8.
Okay, I want you to look really closely at these two problems. At a glance, they look almost identical, right? The only tiny difference is those parentheses on the right. Do you think they're really going to change the final answer that much? Let's find out. So first up, let's tackle the one on the left. We follow the rules we just learned. We square the x first, so that's 8 squared, which is 64. Then we multiply by 3, and we get 192. Okay, got it? 192. Hold on to that number.
But now, look what happens with the parentheses. The game totally changes. Those parentheses are basically screaming at us, do what's inside me first. So 3 times 8 is 24. Then we square that result, and 24 squared is 576. Whoa, that is a massive difference from 192, isn't it?
So here's the big takeaway from this. Parentheses are the boss. They act like a spotlight, changing the natural order and telling you exactly what to focus on first. In the language of algebra, they are, without a doubt, one of the most powerful rules you can possibly use. So we've been cracking these codes, learning the rules, but you might be asking yourself, okay, but what's the real point of all this? Well, let's bring this out of our secret mission and see how it works in the real world. I guarantee you've seen something like this before. It's the formula to convert temperature from Fahrenheit to Celsius. And guess what? This isn't just a random assortment of letters and numbers. It's a perfect piece of algebraic code. It's a tool, a pre-written code that helps us do something incredibly useful.
And this is where it all clicks into place. Every single time we plug in a Fahrenheit temperature for that F, the formula does its decoding work for us. So a nice, pleasant 77 degrees Fahrenheit becomes 25 degrees Celsius. And hey, look, see those parentheses? They are forcing us to subtract 32 before we multiply. It's the exact same rule we just learned, but now it's working for us in a really powerful real-world tool.
Just think about the journey we just went on together. You started by seeing these weird letters as secret numbers. Then you learned the rules of powers and parentheses. And now you can see how those exact same skills power everyday tools. You've literally gone from being a code breaker to a tool user.
Which really brings us to our final thought. You've just learned the fundamentals of a whole new language, a language of logic, of puzzles, of problem solving. But this is just the beginning. The real question is, now that you know how to crack the code, what problems are you going to choose to solve next?